Hi, good day for everyone. Today, as in the part of Python programming videos, today I'm going to discuss about data types, lecture 3. So, in this class, we are going to discuss about the different data types available in Python. So, these are different data types available in Python. Numbers, sequence types, boolean, dictionaries, and sets. These are the different data types available. So, numbers, sequence types, boolean, dictionaries, and sets. These are the 5 different types of data types available in Python. Now we will see about each and every type one by one. Before discussing about data types available in Python, so we need to understand what is the data, and then we will see about their types. First we will see about data, and then we will discuss about their types. So generally data, if you see the textbook's definitions of data, data is nothing but plural of datum. Plural of datum. Datum means a singular word. Data is a plural word. So what is datum? Datum is nothing but a real world fact. Real world fact. If you say this one, what you can say this pen. A pen. So this is a data. This is a datum. Singular. A pen. So a bench, computer, a remote, fan, tube, chalk piece. So such a type of raw facts, a singular fact is called datum. A raw facts, multiple facts called data. It's okay. A technical or textbook definitions. But for understanding, if you see what is data, the sense whatever the input we are giving to the program, that we can call as a data. For example, if you take an example program, a equal to 5, b equal to 10, and sum equal to a plus b, and then print sum like this. In this program, a is a variable, b is a variable, and values given to that a and b are 5 and 10. Now we can say this 5 and 10 as a data to variables a comma b. This 5 and 10 we can call it as data. So sometimes this may be integers, sometimes it may be string also. For example, see, name is another program. Name equal to Sudhakar. Name equal to Sudhakar, and I want to print my name. I want to print my name. Print name like this. This is another program. Okay, this is another program. In this program, variable name contains string Sudhakar. Here variable a contains 5 integer. Here variable name b contains 10. It is integer. Here variable name contains Sudhakar. It is the data here. These 5 and 10 are data here. And suppose if you take another example, subject 1 marks 50, subject 2 marks 60, subject 3 marks 70, and average of 3 subjects S1 plus S2 plus S3 divided by 3. Now S1 contains 50, S2 contains 60, S3 contains 70, but average contains 50 plus 60 plus 70 by 3. It means how much? 180 by 3, 60. Now suppose if you take 75, 185 by 3, somewhere 62 around, 62 point something around it will come. So it's a fraction. Otherwise, we'll take a best example. So if you take another example, a equal to 5, b equal to 6, and if you take average equal to a plus b by 2. So now value for a is 5, value for b is 6. If you take average, how much is the average value? 5 plus 6 by 2, then it is a 5.5. So the average contains 5.5. So this is a fraction. This is a fraction. These are integers or whole numbers. It is string. It is string. See, different types of values you are providing as a input to the program. So in this case, numbers we provided. Here also numbers we provided. Here numbers with fractions we provided. Here strings we provided. Like that we can have different data you can provide as input to the different values, different types of values as input to the program. So these values are called data. So here we can have different types of data. For example, if you see here, numbers we pass. Here also numbers we pass, whole numbers we pass. Here fraction numbers we are passing. Here string we are passing. So such a different types of data, different types of data we can pass. That is the data types means. So what type of data you are passing as input to the your program? That is called the concept of data types. Here integers, fractions, and strings, and there are some other advanced data types called here. See lists, doubles. These are derived from the simple data types. Now we will try to understand all the different types of data types available in Python. So data types available in Python, if you see numbers, sequence types, boolean, dictionaries, and sets. These are the various data types available. Now you have an idea about data and the types of data. So we will give generally while executing the program, we have to provide the input to the programs. That input is called data. That data may be numbers. That data may be string. That data may be list of values sometimes. So different kinds of data we will give as an input to the program. So those are called the data types generally in programming languages. So here in Python also we have 5 different types of data available. These are numbers and sequences, and then boolean, dictionaries, and sets. These are the various types of data types available in Python. Next we will go to Python data types. See the diagram, classification of the Python. So Python data type, numeric type, dictionary type, boolean type, sets, and sequence type. In this numeric type, we have integers, we have complex numbers, we have a float type. We know integers in the sense whole values, 1, 2, 3 like that. And float means fractions, 5.6, 5.7. So decimal fractions, all those things are floating. And the complex numbers, so which are having some real part and imaginary part followed by j. So like that. So 3 different types are available in numeric again. And if you take a sequence type, in the sequence types we have a strings, list, tuple. These are the different types. Apart from these two, we have a dictionary types, boolean, and a set. We will discuss each and every type very in detail now. So we will see now. So there are a few points about data types here. Data types are the classification or categorization of the data items. So whatever the data items we are providing as an input to the program, those data items are classified into different types. Those are called the data types. Those are numerics, dictionaries, boolean, set, and sequence. It represents the kind of value. It represents the kind of value is in operations to be performed. So what is generally this data? It represents a kind of value which is used in the operations. So that is the called data. So since everything is an object in Python programming, data types are actually classes and variables are instances or objects of these classes. So in Python, everything treated as a class. So these data types are also treated as classes, and whatever the variables created, for those data types. Those are treated as instances or objects of that type of class. So that we will discuss about the classes and objects and all those things. Now we will see numeric type. Numeric type means it includes numbers. So numbers may be integers, numbers may be floating point numbers, that is fractions, and real-time numbers, floating point numbers, and complex numbers. These are the three different types of numeric types available. So what are those things? Integers, floating point numbers, and complex numbers. These are the three data types available in numeric type. So first we will see integers. This value is represented by int class. Int class. So class here, class is nothing but a design concept of an object. It is not a real world entity. It is not a real world entity. It is a design concept. It means a class actually does not exist. So class have some properties and methods. With those properties and methods, we can design an object. So it is a design concept. A class is a design concept of an object. Based on that design concept, we can realize, or we can realize an object, or we can create an object based on that design concept. For example, if you take a chair, so a chair can have four legs and some height, length of the legs, some hands, length of the hands, and the back portion, size of the back portion, size of the seating portion. These are all in some parameters will be there. Based on those parameters, we make a design on paper. That is nothing but a class. That based on that design, we can create chairs. Number of chairs we can create. So whatever the chairs created based on those parameters by using some kind of wood, so now that chair becomes a real world entity or an object. The chair design which is on their paper, that is not a real chair. That is a we can say that design concept of a chair. That concept we can call it as a class. That concept having some properties and some methodologies in that. So based on those properties and methodologies, we can realize the objects from the design concept. Similarly, here int is also a class. Class in the sense it has some properties. So based on those properties, we can create an object, integer type of object. That becomes a real world entity. That becomes a data type here. For example, if we take, for example, int, I'm declaring a variable of type integer. Now, if you declare a equal to 5, now this a becomes an integer type. It means it's a real world entity which is having some space, some properties which can store the value 5 in it, in the memory. So, but if you take int, it's a class of type A, but you cannot store values in int. It is not possible. So whenever you create a variable of type int, then only you can store a variable, a value or a data in that variable. So you cannot use for storing data these classes, int class or float class or complex class, like that. You cannot store data in those classes. But in objects you can store the data. So that's what objects are, real world entities where you can store the data or where you can access those objects, and whatever the values are there in the objects you can use. But classes are not real world entities, they are design concepts. From the design concept you can realize a real world entity. That real world entity is called an object. That is the relation between the class and object. This is the concept of object oriented programming. While introducing the Python, I already told that Python is also having one of the greatest feature, that It is objective oriented program. It follows the objective oriented program paradigm. So this is one of the concept of object oriented class and objects. So here a class data type is a int data type is a class, and variable is of that type of object. So for that object you can assign value. For that object, by using that object we can store value, we can access the value, we can use anywhere in our programming in for calculation purposes or whatever it may be, our requirement. Based on our requirement, we can use that values. So that is about object and a class here. So this is true for all data types. Here, the data types are classes, and the whatever the variables created based on those data types are objects of that type in Python. So in numeric type, we have integers, we have a floating numbers, we have a complex numbers. In that integers, int is a class. Int is a class. So we can create object for that int. Then that object becomes a variable of int type, and we can able to store all the integers, positive and negative numbers in that integer object or in that variable. So, but these integer type of variables cannot store the fraction values. Cannot store the fraction values or cannot store the fraction values. That is about the integer. And there is no limit to how long an integer value can be. So there is no limit on that. If you see in C and Java, so if you take integer, again integer, there are different types, short int, long int, like that. So some integers stores 2 bytes, some integers stores 4 bytes, like that. There may be restrictions on length of the integers based on their integers and subtypes of the integers in C. But here in Python, it is not like that. There is no limit on integer value. So you can store any long integer, no issue at all. And next type is a float type. Its value represented by a float class already. So integer, if it is integer, integer class. If it is a float, float class. So, FLOAT, float class. I already told what is class. Class is a design concept, and whatever the object created or a variable created of that type, that becomes an object, or whatever the object created of that type is become a variable. So integer class and float class, these are the types in data types. So it is a real number with the floating point representation. Generally, these floating point variables store the real numbers. Real number, for example, a equal to 5.675. 5.675. This is the float value. 5. There should be some fractions. So a equal to 5.675, b equal to 7.62, like that. So there should be some decimal point and some digits after the decimal points, some fraction values. So such a type of values are called floating point numbers in data types. It is specified by a decimal point. Optionally, the character E, small e or capital E, followed by a positive or negative integer may be appended to specify scientific notations. Yes, sometimes values are huge, bigger values. So we can also specify with the E notation. So that is also possible. And then complex numbers. Complex numbers, there is a data type for complex numbers in Python. So this data type is just like this: real part plus imaginary part followed by j, like this. This will be there. So for example, 2 plus 3j, it is a complex number. Or you can create like this, 4j. This is also possible. There are the different types of complex numbers. For storing these complex numbers, we have data types, a special data type in Python. Okay, these are the numeric types in Python. different numeric types in Python. So suppose if you are working or you are writing a program and already that program has written by somebody, and now you started continuing in that program, and they have defined some variables and assigned some values. So you want to know the type of that variable. So you can easily know by executing this function. There is a function like this type function. So this type function will return the type of that variable, which type that variable belongs to which type or which class, like that. This type of function is used to determine the type of data type. Next, we will see an example. See here the value a equal to 5, and then print type of a, type a, b equal to 5.0, print type of b, type b, c equal to 2 plus 4j, print type of c, type c. This is the program. See the output here. Type of a is class int, type of b is class float, type of c is class complex. This is how it gives the output. So what does it mean? A equal to 5. You assigned a whole number 5 to a. Now, whenever you print this statement, print a type of a, see, this is the function you are passing. So in the previous slides, we have seen, right, type of. See here, type of. In the note also it is there, type of function is used to determine the type of a data type. Here in this program, you assigned 5 to a, and you are calling type of function by passing that a as a parameter to that type function. So the type function now printing type of that a as a class integer. And next in another function, so you are assigning b equal to 5.0, and you are printing type of b by passing b as a parameter to the type function. Whenever it takes b as a parameter, then the type function is returning class float, because b holds the floating point value. And then in the next statement, c equal to 2 plus 4j. 2 plus 4j is a complex number, and you are passing that c as an argument to the type of function. And by taking that c as an argument, this type function is returning class complex here. So this is how we can identify the type of a variable. A type of a variable. Because in Python, so there is no convention that declaring variables with the data type like this, int a or string s or char c, like this. So in languages like C and Java, we can declare variables like that, like this, and we know what type of variable a is while declaring itself. Even if so, with the data type only, we will declare. So we mention the data type and then variable name. This is the syntax in another languages. So the syntax follows like this: data type, variable name, data type and variable name. So in languages like C, Java, this is the syntax. But in Python, that is not the case. But in Python, directly we can use a variable name and then value assign it to that. We can assign the value to that variable. Based on the value assigned to that variable, this type of that variable will be decided by the interpreter. And then see here a equal to 5.0, then b equal to 5.0. Here a equal to 5, b equal to 5.0. Now type of a becomes integer, type of b becomes floating point. And now for c, 2 plus 4j, now type of c becomes complex. So based on the value assigning to the variable, that type will be decided. Based on the value assigning to the variable, the type of the variable will be decided. But in languages like C and Java, while declaring the variable itself, we can declare with the data type. So because that is the difference between the Python and other languages. Okay, there are so many languages we can also declare variables in the same like Python. So based on the assigning value to that variable, the type of a variable will be decided. So like scripting languages, most of the scripting languages follow this methodology of assigning variables. type of the variables and based on the assigning value. Okay, and then we will move on to the next slide. Here, sequence types. Next, see, generally, uh, what happened in numeric types? So there are numeric types. Integers are there, and floating points are there, and then complex are there, right? So in these type of variables, we can assign a single value. We can assign a single value to the variable. For example, if you take a equal to 5, you can assign a single value at a time. You cannot assign 5, 6, 7, 8. So similarly, for even floating also, you can assign 5.5 or 6.5 like that, but you cannot assign multiple values for a single variable. That is not possible, even for complex also. But some situations demands on a single variable name, we need to maintain multiple values. We need to maintain multiple values. In such situations, we need sequence types. We need sequence types. So these sequence types are strings, list, and tuple. They are the different sequence types. For example, if you want to maintain marks of a student, so one of example, marks of a student, otherwise marks. So marks of a student. While maintaining a student record, you need to maintain of marks of the students. So marks of the students can be for 6 subjects, 6 marks will be available. For 6 subjects, 6 marks will be available. So similarly, temperatures of 365 days, temperatures, you need to maintain temperatures of 365 days. Of 365 days. There may be 365 temperatures. But if you want to declare a 365 variables for maintaining 365 temperatures, so it is a problem. What actually problem means, it has to maintain all the variable. It's required some memory for storing all the variable names, identifiers, and some metadata about those variables. All those things are there. So it takes some more time. Even accessing also, it is difficult. Programmer need to remember all the variables and all the variables while programming. So such a type of difficulties are there. Because of that, we have a sequence types where we can maintain a list of values under a single name. Even we can maintain tuples or lists, tuples, strings. These are the different types in sequence type. This is the advantage of these sequence types. So under a single name, we can maintain multiple values. Okay. So in Python, sequence is the ordered collection of a similar or different data types. This sequence in Python, the sequence means it is an ordered collection of similar or different data. It may contain similar data types or different, means heterogeneous, homogeneous and heterogeneous. It can contain anything, homogeneous values or heterogeneous values. It means the same kind of values it can contain, or a different kind of values, combination of different kinds of values it can contain. Sequences allows to store multiple values in an organized and efficient fashion. There are several sequence types in Python. So first one is a string, second one is list and tuple. Now we will see one by one. String. Strings are arrays of bytes representing Unicode characters. Strings are nothing but arrays of bytes. So you need to understand there are a few new words here. Arrays, bytes, Unicode characters. You need to understand these things. Array is nothing but a consecutive memory locations. Array is nothing but a consecutive memory locations or a bytes. Arrays of bytes. In the sense, a byte is nothing but a memory space required for storing 8 bits. That is called a byte. or 8 bits equal to 1 byte. 8 bits equal to 1 byte. Then what is 1 bit? 1 bit is nothing but a memory for storing either 0 or 1. That is called a bit. Such type of 8 bits, called a byte. Okay, I will see very clearly. Memory for 0 or 1 is called bit. Such 8 bits is called byte. 1 byte. Memory organization. 8 bits called 1 byte. Okay. Such a type of bytes, strings are arrays of bytes. Say, suppose like this. So this is a byte. 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 Like this, arrays sequence. Arrays of bytes representing Unicode characters. This is called an array. Sequence of bytes is called an array for representing Unicode characters. What is the meaning of Unicode characters here? Unicode characters in the sense. So Unicode is a standard for representing the characters. So worldwide there are some consortiums. Consortiums are nothing but organizations, worldwide organizations. They made some rules and regulations so that all the people has to follow those rules and regulations to avoid confusions and to make proper communication and to avoid confusions. For example, if you take these are the symbols we are using as an alphabets in English: A, B, C, D, E, F, like that up to Z. So A means everybody write like this only. B means everybody like this only, because it is a standardized way of writing alphabet, English alphabet. Somebody defined these alphabets and everybody is following. Okay, and if you ask anybody write 1, 2, 3, 4 like that, they'll write like this only: 1, 2, 3, 4, 5. They're the symbols representing numbers, and entire world, everybody following these symbols only, so that everybody can understand easily and everybody can able to communicate with this type of symbols and these things. So because it sets a standard for following the numbers and it sets a standard for following alphabet. So similarly, even for coding, it means in programming, there are some consortiums or worldwide organizations. They made some rules and regulations so to follow everybody to avoid the confusions. So in some areas, somebody use some words for some purpose. In another area, those words may have a different meaning. So if there is no any such a type of rules and regulations, standards throughout the world, then entire meanings will be changed from place to place. Then it leads to some confusions. So because of that, some of the worldwide organizations for regarding programming or whatever it may be, in many cases, they set some standards. So such a type of one of the consortium is Unicode consortium, which sets the standards for the characters, representation of the characters. So these are talking about those Unicode characters. Okay, it's nothing but alphabets. How to represent the alphabets, how to write strings and all those things. They have some rules and regulations. Strings are arrays of bytes representing Unicode characters. That's it about it. A string is a collection of one or more characters between in a single quote, double quote, or triple quote. A string in Python, how you can define a string? A string is nothing but a collection of characters. Collection of characters. See, we will see now. Collection of characters. For example, we'll take a name. In this, I have written X, Y, Z like this. For example, name equal to XYZ. So this XYZ I written in between double quotes. So now this becomes a string. Now this becomes a string. If you see X, Y, Z individually, these are the characters. The combination of these characters or a collection of these characters, we can call it as a string. Collection of these characters, we can call it a collection of these characters, we can call it as a string. So that can be mentioned in between double quotes or single quotes or triple quotes. We can use anything in Python. Anything is possible. Anything is valid in Python. So suppose if you name one, you declare a name one like this. Name one equal to so A B C D 1. Name 2 equal to A B C D 2. Name 3 equal to A B C D 3. So in single quotes ABCD1 is valid. In double quotes ABCD2 is valid. In triple quotes ABCD3 is also valid. So these are the value strings for declaring. Say a string is a collection of one or more characters between a single quote, double quote, or triple quote. In Python, there is no character data type. A character is a string of length 1. Here we need to understand. That's why I made no character data in a different color. We'll see now. In other languages other than Python, if you take a C or Java, we have a data type called character. Character stores only single character. Character type of variable stores only single character. That's why here see the character is a string of one length. So it required 1 byte of memory. It required 1 byte of memory. 1 byte of memory in the sense 8 bits of memory it is required character. So in the case of Python, such a type of character type of data is not available. So everything is string here. So that string, if you declare any character, that is the length of one string. That is a string but length of 1. Okay, that is how we can declare string types. So it is represented by the string class, str class. Str is the class for declaring the string type of variables. Here also in Python, we never mentioned data types in front of the variable names. Based on the values assigned to the variables, the type will be assumed by the interpreter. Okay. Next we'll move on to next slide. So in Python data, this is an example I am showing here. See now, define string in Python. All of the following are equivalent. So the first variable is my string. My string is equal to hello. Hello is there in single quotes. See, single quotes I have written hello. In single quotes I have written hello. Print my string. I'm printing my string there. And next, the first same. And next, one more time I declared my string variable, and in double quotes I have assigned hello string to my string and printing my string. And third time, again I am using my string and assigning hello between triple quotes and printing my string. See, in these 3 times, okay, and last statement, a triple quotes string can extend multiple lines also. So my string, hello, welcome to the world of Python. Whenever you are using a triple quotes, you can extend that string into multiple lines. If there is a long string, so which can be, there is a possibility for extending multiple lines. So in such cases, you can use the triple quotes. And I'm printing my string. See the output, how it is coming. In the first case, my string hello in single quotes. This one is the output. Or hello in double quotes, this one is the output. Hello in triple quotes, this one is the output. Hello in triple quotes for extended lines, this one is the output. This one is the output. This one is the output. This is how all are same. There is no difference between hello, hello, hello for three hellos. So hello in single quotes, hello in double quotes, hello in triple quotes, there is no difference. All are strings. These three considered as same strings. So there is no difference. So that's why we can declare, uh, while declaring we can use it while declaring the strings or while initializing the string variable with any string, we can declare a string within single quotes or by using a double quotes or by using triple quotes also. There is no difference. You can use anything. Why we are stressing like that means in some languages, so for there is a specific use for single quotes and there is a specific use for double quotes. Because, for example, if we take a C, for a character, you have to use single quotes. For a string, you have to use the double quotes. So in languages like C, Java, there are specific meanings for single quotes and double quotes. But in Python, while initializing strings, you can use either single quotes or double quotes or triple quotes also. So all treated as a same. Okay. And next, we'll move on to next slide. In Python, individual characters of a string can be accessed by using method of indexing. So how to access these strings? So while defining a string, we said that string is nothing but an array of characters. Array of characters means it is a collection of different characters stored in consecutive memory locations. Each and every character requires one byte of memory. Like that, continues. It is an array of bytes. Array of bytes, each and every character requires one byte, and a string is nothing but a collection of or array of bytes. That is the definition of a string. It means if you want to access such string, accessing means reading that string already is stored in memory. If you want to read that string letter by letter, you can also read. That is, we can call it as an accessing. If you want to access that string, we need index. Index means for each and every character stored in memory that is having a position. So that position is called the index number. Now see in this diagram, gigs, that is the string stored in the memory. This string is having 13 characters. It is a length of 13 characters, 0 to 12. So these are the position. The first letter positioned at 0, the second letter at 1, third letter at 2. Index of an array starts from 0. And ends at n minus 1. N is the number of characters in the string. 0 to n minus 1 is the size of a string. So it is a collection of 13 characters. So its index starts, it's the starting position and the ending position. Starting position starts at 0, ending position ends at n minus 1. N is the number of characters in the string. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Total 13 characters are there, starting at 0, ending at 12. 13 minus 1 is 12, so ending at 12. If you want to access each and every character, you can access with the index. So, for example, the same string, you take it as a name equal to, for example, gigs, like this if it is there. So, name of 0, it gives G. Okay, we will see with example. And not only that, if you want to access from end of the string, we can use these values. From starting 0, from ending -1, -2, -3. If you want to access yes, so you can pass like this -1. Name of -1. It gives yes. Okay, we will see in example. This is an example. See here, string 1 equal to Institute of Aeronautical Engineering. So I have stored Institute of Aeronautical Engineering. This is a string, and that string is stored in string 1 variable. Now I am printing that print initial string. So print string 1. The initial string, initially Institute of Aeronautical Engineering is printed. Now what I am trying to print, printing first character. So I am printing the first character from this string. What is the first character from this string? It is I. So if I want to print I have to use the, if I want to print the characters, individual characters in the string, I need to use the index of that character. So which character you want to print, you need to use the index of that character. So for that purpose, here what I want to print, I want to print the first character of this string. First character of this string. What is the first character of this string? I is the first character of the string. So if I want to print the first character of the string, I need to know the index of the string. Here we have a first character of the string at indexed at 0. Second character of the string is indexed at 1. Third character of the string is indexed at 2. Like that, we can make a index values. So that's why if I want to print the first character, print string 1 of 0. These are brackets. So between the brackets, you can mention the index number. Based on the index number, that character will be printed. See, first character of a string is I. Why it prints I? Because I passed string 1 as 0. Suppose I used a statement here like this: print of string 1 of 5, like this. What will be the output string 1 of 5? You can calculate here: 0, 1, 2, 3, 4, 5. Yet the index 5, t is there. At index 5, t is there. Now it prints t. It prints t. Okay, like that it prints the output. Okay, next, see, last character. If you want to print the last character, you can pass -1, because here we have there is a facility in Python. If you want to print from last, you can use the minus indexes: -1, -2, -3, like that. In language like C, this facility is not there. If you want to print a last character, you need to find the string length, and then you need to accessing string length -1. You have to pass here string length -1. So in this case, 13, right? So in language like C and all those things, you need to pass like this, like name of 12. Name of 12, like this you need to pass. But here, so it is somewhat difficult because you need to calculate the string length. Here it is okay, 12 characters or 13 characters. Even that also you need to count how many characters are there. So by programmatically you need to use a function called string length function, or you need to use a for loop to find the length of the string, or while loop to find the length of the string. So all these things are there, and then you need to identify the last letter index, last character index, and you need to pass that last character index to access the last character. So, but Python resolved all those things, and it gives so negative numbers starting from -1. -1 indicates the last character. -2 indicates the last but one character, like that, so on till the first character. So this is how you can access strings in Python. Okay, see here, last character of a string. What do you pass? One -1. You pass it. So because of the -1, it returns G. Why it returns G? What is the last character in the string? G. Suppose in this place, if you pass like this -2, it returns N. N will be the output. If it is -2, if it is -3, I will be the output. Okay, if it is -4, R will be the output. Okay, like that you can print each and every character from the end by using negative indexes. You can print from by passing the positive indexes from 0, from starting to ending, from 0, 1, 2, 3 onwards, from starting to ending. This is how you can access the strings. Okay, so While doing programs, we can learn more and we can understand more about these strings. As an introduction and first unit, this is enough. And next thing is Python lists. Lists are just like a dynamically sized arrays declared in other languages. For example, vector in C++ and array list in Java. So these are dynamically sized arrays. What is the meaning of dynamically sized arrays? This is the word. These are the words you need to understand. Dynamically sized. It means even after declaration of the list, if you want, you can extend the list. It means you can add some more values to the list if you want. Or if you want, you can remove some values from the list. Static in the means you cannot change. But dynamic means you can extend the list or you can compress the list. Whatever the operations you want, you can perform on. That is the dynamic sized arrays. So in simple, we can say a list. Even in general, a list. What is a list? A list is nothing but a collection of things. Collection of things enclosed in brackets here. Collection of things enclosed in brackets. That is called the list generally. And separated by commas. For example, we take 1, comma, 2, comma, 3. Here, there are three strings are there. 1, 2, 3, like that. 3 strings are there. 3 strings are separated with the commas and enclosed by brackets. Enclosed by brackets. And the name given to that entire list is variable. With the only single name variable, you can access 3 strings. 1, 2, 3. 3 strings. So that is the main advantage of this sequence types. With a single name, we can represent many number of many number of values. Okay. When you print var like this, it prints 1, 2, 3. Whatever the strings what are the values you maintain in the string or you entered in the string, all those values will be printed as an output when you try to print it by using a print variable. Okay. Lists are the simplest containers that are an integral part of the Python language. Integral part of the Python language in the means it comes with the Python language. Lists need not be homogeneous always, which makes it the most powerful tool in Python. What is the meaning of homogeneous? And it means list need not be homogeneous always. And it means most of the times lists maintains the homogeneous values, but it is not mandatory. Homogeneous values in the means same kind of values. See here, I have given 3 strings. So these are the homogeneous values. There is no rule that a list can contain only homogeneous values. You can have a different kinds of values also. No issue with that. You can maintain different kinds of values also. A single list may contain data types like integers, strings, as well as objects. This is the meaning of above statement. So homogeneous, not to be homogeneous always. What does it mean? Next statement is explaining. So a list can contain integers, a list can contain strings, a list can contain objects, or a combination of all the things a list can contain. That is the meaning of need not be a homogeneous always. But most of the times when we declare a list, we use homogeneous values, but it is not necessary to containing only the homogeneous values in lists. We can also maintain heterogeneous also. Heterogeneous means a different kind of values we can maintain as a list. No problem at all in Python also. Lists are mutable and hence they can be altered even after their creation. What is the word meaning of mutable? Mutable in the sense you can change. Even after creation of the list, you can change. That is the definition. Definition itself is saying lists are just like a dynamically sized arrays. What are the lists? They are dynamically sized arrays. So because you can change the size of an array and values of array even after size of the list and values of the list even after their creation. That is possible. That's why these are called mutable. If it is not possible to change, then they are called immutables. Immutable and immutables. Okay. So here I want to give mutables and immutables. And then next I will move on to next slides. See, with an example, I'm taking an example. Create a list with multiple distinct or duplicate elements. So see here example. List 1, 2, 4, 4, 3, 3, 3, 6, 5. So it is, you can have duplicate values in a list while declaring a list. No issue. It is valid. And creating a list with the type of mixed type of values. So 3. See here, list 1, 2, 3, 3 is a string, 4 is a number, 5 is a string, 6 is a number, 7 is a string. So when you are mentioning values in a list, if they are numbers, no need of any codes, single code, double code, or triple code is not required. You can directly mention the numbers in the list. But while mentioning strings, you need either single quotes or double quotes or triple quotes you have to use. Okay. Here see, this list contains a combination of both numeric values and string values. Both of them. So these are valid. No problem at all. This, because of that, without any error, it outputs. The first one is it prints all the integers, whatever are there in the list. And second one, it prints all the list items, whatever are there in the list. 1, 2, 3, 4, 5, 6, 7. In that 1, 2, 4, 6, these 4 values are integer types. 3, 5, 7. These 3 are of type of string. So we can have no issue at all. Not only that, we can also create an empty list or a blank list. No problem. That also possible. See. So list without having any values, creating a list, and I'm printing the list here. It prints like this. So there is no values. And creating list with numbers, it prints like this. And creating a list with strings, and I'm accessing list of 0 and list of 2. What is there at list of 0? At list of 0, 1 is there. At list of 2, 3 is there. Just like how we access the characters in the strings by using index value, similarly, even in the lists, we can access each and every element of a list by using its index. So index is nothing but an integer value which represents the position of that element. So position of the 1 is here 0, position of the 2 is 1, position of the 3 is 2. Okay, that's why list of 0 prints 1, list of 2 prints 3, 0, 1, 2. Okay, like that by using index values, we can access the list of items. Accessing, that's what I explained already this thing. Next, moving on to negative index. Yes, similarly, negative indexing means beginning from the end, -1 refers to the last item, similar how you access the characters from the end in the case of a string with the negative indexes. Similarly, in the case of list also, you can access the list items from the end with the negative indexes. That is also possible. This is the example here. The list is defined 1, 2, 3, 4, 5, 6, 7 with a combination of numbers and strings, and accessing an element using negative indexing, accessing elements using, see, print list -1. I'm passing the -1 index. -1 index indicates the last item of the list. What is the last item of the list here? 7. That's why 7 is printed. And here, print the third last item of the list of -3. What is the third last item? -1, -2, -3, which is the 5. So 5 is printed here. So 7 and 5. It is how you can print the values. Next, the third one is a tuple. Tuple is a collection of Python objects, much like a list. It's also just like a list. Then what is the difference between a tuple and a list? Tuple is a mutable. List is a mutable and a tuple is a immutable. The sequence of values stored in a tuple can be of any type and they are indexed by integers. Similarly, all the characteristics are similar to lists, only except one thing. So the values in tuples you cannot change. The values in lists you can change. That is the difference, major difference between. So accessing just like a string or just like a list, you can access the elements of the tuples. It is also a collection of items only. The values of a tuple are syntactically separated by commas, just like in list. Although it is not necessary, it is more common to define a tuple by closing the sequence of values in parentheses. Parentheses means this is called the parentheses. So in programming language, generally we use three types of brackets. First one is this one. This is called braces. This is called parentheses, and this is called brackets. Okay, don't call them as a flower brackets. These are the square brackets. All are having a different names. This is called braces. This is called parentheses. This is called brackets. So these tuples used brackets. Sorry, parentheses. Tuple used parentheses. List used brackets. Okay. Let's have to understand the Python tuples more easily. Creating a tuple. In Python, tuples are created by placing a sequence of values separated by comma with or without the use of a parenthesis for grouping the data sequence. So you can use the parenthesis or you cannot use parenthesis, no problem. See, this is the example for tuples. Tuple 1, empty tuple is created here, and printing the empty tuple, print tuple 1. This is the output, and creating tuple with the use of strings. So 3 strings creating as a tuple. So while printing, this is how we can print. And creating a tuple with the use of a list 1 equal to 1, 2, 3, 4, 5, 6, and print tuple of list 1. If you pass list as an argument to the tuple, so that list will be treated as a tuple. So this is the output 1, 2, 3, 4, 5, 6. And creating a tuple with the use of a built-in functions, tuple 1 equal to tuple of institute. Then when you print a tuple, it creates with it separates the characters and make it as a tuple. So like this you can create a tuples in Python. So this seems to be like list, but then what is the difference? So lists are mutable, these are immutable. That is the difference. What is the meaning of mutable and immutable? Lists, after even creating the list, you can, if you want, you can change the list values, but in tuples it is not possible. Accessing tuples just like lists and strings by using the index values. So from starting to ending, positive indexes from starting from 0 to n minus 1. From accessing list tuple items from last to beginning with negative indexes starting from -1 to -n. So that is how you can access the tuple values. Now, so you can also unpack the tuple. So what is the meaning of unpack? Tuple is nothing but a packing of different items, a list of packing of different items together. Unpacking means so you are separating all the tuple items into different items. So that is how here example I taken. So tuple 1 I created a like this, and tuple 1 of this is accessing, and then see tuple 1, 1, 2, 3. With 3 strings I am creating a tuple 1 here. And in this tuple, this line unpack values. So a comma b comma c equal to this line. A comma b comma c equal to tuple 1. This count, the number of variables must be the number of items in the tuple. That count should be similar. You need to maintain proper count. If there are 3 items in the tuple, while unboxing or untupling, you need to maintain 3 variables here because 3 items are there. You need 3 variables while unpacking the tuple. So like this you can pass. See, tuple, T-U-P-L-E, tuple equal to, it is like this, 1, 2, 3. Okay. So it is a pack of 3 strings, 1, 2, 3. Now you are unpacking the tuple. How to unpack the tuple? So how many strings are packed together as a towel? So how many strings are there? How many items are there? Three items are there. One, two, three. So you need three variables while unpacking because three items are there in that tuple. So assign the tuple one here. So the same tuple you are passing here. Now for A, in A, 1 will be stored. In B, 2 will be stored. In C, 3 will be stored. Like that, you can unpack the tuple. See, while printing A, comma B, comma C, it is giving 1, 2, I think 3 is not printed here. 3 is also there. Okay, that is how you can unpack variables. So, thank you. Thank you for today.
Like, share and subscribe. Hit the bell icon for more updates.